Okay, class. So in the last class on Tuesday, we had started with this unit ray optics, and we have discussed briefly about what is this unit all about, and we have seen refractive index. I think only till refractive index only we did it. See, refraction, we're not going to do the details because as I've mentioned you this fact already, that reflection has been recently added in your syllabus. So chances of reflection questions coming in your syllabus is much more greater than the other questions which are possible. Fine. So what we'll do, we'll start with reflection, simple reflection that is present in your syllabus. This reflection includes what? The properties and the laws of reflections. Then you have spherical mirrors with you, formation of images by concave mirror, convex mirror, and mirror formula. These all topics are included under reflection. Obviously, it won't be completed in today's class only. We'll use the next class for completion of reflection, but this is one of the major topics as well. Reflection, then the refraction, optical instruments. These three are the major topics. In between, you have little topics in between them. So, reflection. See, for reflection, understanding reflection, if you have a surface, let's say this is a plane surface that we have. If a ray of light is incident on this, this is the incident ray. Now, what all things are possible? First possibility is that this ray of light can get exactly, it can reflect itself. Means reflection is what? It's just the bouncing back of light. So as the incident ray strikes on this surface, it will get reflected back, means bounced back. Now, at what angle, in which plane, all these things will be dealt later on. But right now, what you have to understand, you just have to understand that if incident ray is falling on a surface, then one possibility is that it retraces its path. This ray is known as the reflected ray. And the phenomena that occurred over here is reflection. Reflection means this bouncing back of light. Second thing that is possible over here is that the ray of light, some portion from this ray of light, almost 1/3 of this portion, this is also a possibility that 1/3 of this incident ray that is coming from your light source, wherever is your light source, it can be absorbed by the surface. Now, absorbing of a surface and all these phenomena, that depends on the material, what kind of material you have, what are all the properties of the materials that you have. But what you have to understand, either it can get reflected, no passing through the surface. Second point, it can pass through the surface, but it can be absorbed within this. So second process that is possible over here, this is absorption. No need to depict absorption, just write absorption. This will show you that the process of absorption has taken place. And the third thing that can occur is that it can transmit the light back to its surface, which means the light ray that is coming, it may not travel its exact path, but it may get bent. It may bend it. So this bending of light from one medium to another medium that occurs, this is known as refraction. So this ray of light becomes refracted ray. And this phenomena is refraction. Fine. So three things occurred over here. One is this reflection occurred. Second phenomena is absorption. Third phenomena is refraction. Somewhere you can see transmitting is also given. When I think in your heat lessons also in class 11th, you must have done this. Transmission of rays also occurred, of heat waves. Specifically, we study for heat waves. So reflection, you can take it as transmission of light back, but reflection is a separate process. Now, when we study reflection, we have to consider reflection's laws. Laws of reflection and refraction remain the same. It's just that the definition changes. Reflection you've understood, it's just the bouncing back of light. An incident, a ray of light will be incident on the surface, it will get bounced back. Now let us talk about how will it get bounced back. The reflection that will occur, will there be a particular sequence? Will there be a particular plane? How will this reflection occur? For that purpose, we have laws of reflection present. There are laws of reflection which are present. So laws of reflection, all of you must have at least once did it in your lower classes, 9th, 10th, I think 10th reflection, and this optics part is included. So first law of reflection says that, see, you have to understand a term that is angle of incidence. Now angle of incidence, which I am depicting by a small I, this is equal to what? This is equal to angle of reflection. That is your first one. Now I'll tell you what is meant by angle I and angle I. See, I is what? It's the angle that is formed between the incident ray and the normal. An angle of reflection. This is angle formed between reflected ray and the normal. Just understand what is meant by the first one. It's easy, very basics. All of you will be able to understand this. See, this is a surface that you have, plane surface that you have. Okay, Samya, you have also joined. So Samya, you will continue here only?
Yes, ma'am.
Okay. Is Zen also present? Okay, Zen is also here. Fine. Now see, a ray of light is incident. This is an incident ray. Fine. So this is an incident ray. Perpendicular to the surface, we drop an imaginary line, you can say, which is referred to as the normal. Remember when we did electric flux, when we did magnetic flux, what was the definition of it? We used the term that a perpendicular number of electric field lines that are normal to the surface per unit area, that is different, or number of magnetic field lines crossing a unit area normally. So normally means what? In an abnormal manner, not in an abnormal manner. That's a different term. Normal here means at 90 degree. Fine. Normally means 90 degree. So here also, if you have a plane surface, on the plane surface, if you drop a perpendicular, this forms your normal. You can say this is a normal. So here at every surface, whenever incident ray of light will be there, a normal will be drawn on it. So this angle drawn between the normal and the incident ray, this is known as angle of incidence. Some students make this as angle of incidence because it is making with the normal vertical axis, horizontal axis. Do not confuse it with it. Incident ray and normal ray. So angle formed between them gives you incident ray. Then this gets reflected. This is your reflected ray. This angle that you have, this is angle of reflection. Angle formed between the normal and reflected ray. Fine. Angle formed between the normal and the reflected ray. So laws of reflection says what? That this angle of incidence has to be equal to angle of reflection. It cannot happen that a ray of light is getting reflected from a same surface with a different angle. If this angle of incidence is 30 degree, angle of reflection will always be 30 degree. no matter whatever condition is provided. So angle of incidence and angle of reflection are always equal. Now, the second law says what? Two laws of reflection are there. Second law says that, see, three rays we have studied right now. Two major rays, incident ray and the reflected ray. Regarding the normal, remember, all these three, wherever you will draw the normal, all these three will be in the same plane. Planes we have already discussed, class. XY plane we have seen, YZ plane we had seen, ZX plane we have seen. This plane is known as XY plane. This plane is known as YZ plane. And this plane is known as XZ plane. Any confusion from the basics, you please let me know. Either type it in the chat column. Let me know wherever you have the basics. So now what will happen if the incident ray is lying on this surface? For example, an incident ray has struck the, let's say, XZ plane. Fine. A ray of light is incident on it. Now the normal will not be drawn downwards in the XY plane. Normal will also be in your plane in which incident ray is lying. If your incident ray is lying in the XZ plane, then the normal will also be in the XZ plane, reflected ray will also be in the XZ plane. So second law says what? All the three, incident ray, normal and reflected ray, lie in the same plane. This says that all the reflected ray incident ray reflected ray and the normal all lie in the same plane. So this means what? These are your axes, y, z, x. So a ray of light, if this is incident here, so the normal will not be drawn over here and the reflected light will take place. Normal will also be drawn here, reflection will occur here. These axes, these planes will have no role then. This YZ plane and the XZ plane will have no role over there. Only this plane will be involved. Fine. So note it down till here. Let me know. Is it clear to all of you?
Yes, ma'am.
Note this part down. Any doubts? This is actually a very basic part that we have covered. We'll start with spherical mirrors. But just note this down. Samya, how much have we completed together in that batch? EMI you have completed? No, EMI is left. Okay, Zen, you have not been added in the group. I'll add you today. Because messages and reminders for WhatsApp and other contexts also, even some materials, I send it on the WhatsApp. Zen, what's your full name? Is it Zen Ahmed? Just let me know. Please correct me. Zen Hassan. Okay. Zen, just check whether you've been added on the group or not. So let's start with spherical mirrors now. See class, for reflection part, for reflection portion, you have spherical mirrors. For refraction, we'll be having lens. And concave mirror is important from the point of view of spherical mirrors, and convex lens is important from the point of view of lenses. Concave mirror will be used more than convex mirror in your questions. Now see. This is a hollow sphere, hollow spherical mirror or hollow sphere, let's say. Fine. From this, if I cut a portion, a crescent shape I'll obtain a crescent shape. Now see. This is one and this is one. Now see, if I take this one sphere, this is what is just a part of the hollow sphere. I've just cut this sphere and I've taken the part of it. Now, if I am applying silver polishing on this side of the mirror, this is which side? This was the mirror. At this part, I have applied the polishing. You can see here. This part I have applied the polishing. So what is happening? Here, all the light rays that will fall, they will come from this part and will get reflected over here. This part has now been silvered. So this cannot act as a reflecting surface for you. This side has been blocked. So a mirror in which bulged part is silvered and inner hollow acts as surface for reflection. This mirror, this type of mirror is known as a concave mirror. This is known as a concave mirror. Now, if I paint this surface, if I apply silver polishing to this surface, see this surface is now acting for reflection to occur. Now, any ray of light that will come, it will fall on this and get reflected. Bulged part now acts as surface for reflection. And inner hollow part, this has been silvered. Silvered, you can say, polished, you can say. So this type of mirror is known as a convex mirror. Concave mirror, we'll be depicting this concave mirror by this symbol. So concave mirror, this. We'll depict it like this. This outer part that is silver and reflection will occur here. And for convex mirror, we'll be depicting it by this symbol. These rough lines show that this has been silvered or painted, fine? Because obviously you cannot color it and draw it every time. Now, one more thing, since we are discussing the mirror, so what is a mirror? Mirror is basically part of a sphere. Agreed? We have cut this part of the sphere. Fine. Now, depending on the silvering, depending on the polishing, depending on the type of reflecting surface that is available, you have the types of mirror which are present, be it convex, be it concave. Got it? Part of a hollow sphere. This was a sphere. From that, a part has been taken that we draw as curved mirror. I'm not talking about plane mirrors. I'm talking about curved mirrors. Spherical mirrors. In simple language, we are dealing with spherical mirrors. Plane mirror is different. The mirror in which you see yourself, that is a different mirror. That is a plane mirror. Now, one more thing. Let's just understand certain terms. Now, this part I have used for the mirror, but it was a part of a hollow sphere. Initially, it was a part of a hollow sphere. So there will be a center of the sphere, which we call as the center of curvature. So it's a part of the sphere. From the complete sphere, you are taking the center of it. Now, when we'll draw the mirror, we'll be considering this for our better understanding. But you have to remember that this was actually the center of the sphere. So it's a sphere. It will be having a center and it will also be having a radius. So radius will be radius of curvature. Radius is radius. R is radius of curvature. Then see, if I take and join the axis or the diameter of this. See, if I join this diameter, there will be an axis that I'll be getting, which will pass through the center of curvature. This axis is known as principal axis. This axis is known as principal axis. The point at which the principal axis and the spherical mirror cut each other or intersect each other. This is known as the pole of the mirror. Fine? Pole of the mirror. Pole, principal axis, center of curvature, radius of curvature. Then all the rays of light which will pass through the or that will strike the surface, the spherical surface, they will appear to meet at a point. That point at which they will meet each other, that point is known as focus or focal length. Focus, mainly we say focus simply, or you can say principal focus also. Fine. Now this length of or the distance of the focus from the pole or the separation between pole and focus, this is known as focal length. Got it? Focal length, radius of curvature. This complete was radius of curvature. This is just the focal length. Now, if you look at this cut part, this line, I'm showing that I have cut it from the sphere. Now here what will happen? Let's name this. This is A, this is B. This part of mirror exists. See this part, the part that has been cut. From here also light rays will enter. So this is an aperture. This is your mirror. So this is an aperture, no? From where the light rays will fall. This acts as an aperture. Since it is a straight aperture, it forms a straight line, this aperture. If you join a straight line, it will enclose it. We call this AB as linear aperture. And this curved part, this APB, this part that you are able to observe, this part at which the light rays will actually strike on, this becomes your angular aperture. So linear aperture was what? This part is linear aperture and this part is your angular aperture. So linear aperture, angular aperture, principal axis, pole, focus, focal length, center of curvature and radius of curvature. All these terms are important. You have to remember all of these terms. Fine. Principal axis, radius of curvature, pole, center of curvature, all these terms. Now see, nobody is going to ask you a direct definition on this. But these terms you should be aware because constantly we'll be using and dealing these terms. Not even if certain terms do not get used in reflection, that will be used in your refraction. Before we move on to the sign convention, I think note it till here. That is better. Just note down till here. Any doubts you have, please ask me, class, because this is the very basic part that we are doing. Any doubts, any queries, please let me know. I'll clarify your doubts. See, focus means what? Focus is the point at which all the rays, first what will happen? Your mirror is there. Ray of light will be incident on this. It will get reflected. So after reflection, you will not have a single ray in your ray diagrams or in natural also in your normal daily phenomena. So you don't have a single ray. So what happens? All the rays that are present, that will come. When after reflection, they will either diverge or converge at this point, which is known as the focus. Right? Either the rays will converge at this point or the rays will diverge from this point. So this point where reflection occurs, this is known as focus. All the rays will meet. Image can also be formed here. You can keep the object as well. Got it?
Yes, teacher. Thank you.
Okay, let's see certain sign written till here.
Yes, teacher.
Okay. Let's see certain sign conventions that are present. The way you have sign conventions whenever you have two directions or two planes involved, like for your relative velocity, which you must have studied in your class 11, or in normal vectors also, if you take right side as positive, you tend to take the left side as negative. If upwards is taken as positive, downwards is taken as negative. So we have to choose the sign conventions whenever we use any vector quantity or whenever we have any quantity, physical quantity that exists, be it vector or scalar. Likewise, here also ray of light will fall on the mirror. There, according to the laws of reflection, it will follow its reflection path. The image will be formed. But image can be formed behind the mirror. Image can be formed in front of the mirror. Or what is possible? One more possibility is there, that the image can be formed below the principal axis, image can be formed above the principal axis. So many possibilities are there. So how can you differentiate between this? By just looking at a figure that is given. If I say -4 centimeter is the object distance. So by looking at -4 centimeter, you should be able to analyze that 4 centimeter is the magnitude of it. Negative sign is depicting that it is kept in front of it like this. So that's why sign convention is very important. Now, according to the sign conventions, let me draw it. This is your mirror. This is the principal axis. Wherever you're not able to understand, please let me know. This is a completely different topic. It is not related to your electrostatics, not related to your magnetostatics. That book 1 is over. Book 1 is interrelated within itself. But this optics is a separate topic and a separate unit. So wherever you have difficulties in this lesson, please ask and get your concepts clear. Now see, first sign convention says that all the ray diagrams are drawn with the incident ray that is traveling from the left to the right. This is the direction of incident ray. Why are we drawing this? Why is this point necessary? That you will see furthermore. Because certain sign conventions are based on this. So incident ray, its direction is taken, or the incident light travels from left to the right, means towards the mirror, basically. From this diagram, I can say this. And all the distances, the starting distance, how will you go? If this here I have an object here, how will you measure? Will you measure this part or will you measure this part? You can have two possibilities, no? So remember, you will measure this. Why? Because all the distances are measured from the pole. From the pole begin your calculation. An object has been, or let's say an image has been formed here. Will you consider this length or this length? You will consider this length because this is what? This is the distance that is taken from the pole. And from the pole only you will take, and all the sign conventions will be formed accordingly. So second point says that all the distances are measured from the pole. Third point says that all the rays or all the distances that are measured in the direction of incident ray. In the direction will be this. So these distances that are measured in the direction of incident. It means if incident ray is falling from left to right, the distance that will be taken from here, this will be left to right. These distances are taken as positive, and the distances that are opposite to the direction of incident ray, those distances are taken to be negative. We'll see all these things in detail, so you'll be able to remember, but for that time, just learn these parts. Now, any object's height or image's height that is formed above the principal axis. So this height that is formed above the principal axis, you take it as positive, and the height that is formed below the principal axis of image, of object, whatever, that is taken as negative. Now I'm writing and repeating the points because this is important. This is your very basics. So I'll repeat all the points. Please any query in whichever point you have, let me know. I'll repeat that point once again. First point, all the ray diagrams. We are actually preparing ourselves for ray diagram. Any ray diagram can be asked to you. Ray diagrams are drawn with the incident ray traveling from left to right. First point. So clear? Left to right. Left to right means what? You're with respect to the mirror. You draw it mainly with respect to the mirror. Second point, distances are measured from where? What is the reference? Focus, center of curvature, pole, principal axis. What is the reference point where from which we begin our distance? Pole. Yes, Fatima. This is pole. So all the distances are measured from the pole of the mirror. Third point, all the distances that are measured in the direction, all the distances measured all the distances measured in the direction of incident light are positive and definitely an opposite point will be what? All distances that are taken in opposite direction. Of incident ray are taken are negative. Fifth point was about the height. Third and fourth were about the distances that are measured. Height measured upwards and perpendicular. Heights measured upwards and perpendicular to the principal axis. Are taken as positive and just opposite to it measured downwards and perpendicular to the principal axis are taken as negative. I hope it's easy and clear. If any difficulties, let me. This understand and usage of this, no, basically, you can understand height upwards is positive, height downwards is negative. What to understand this? Mainly the usage and application you will understand as we'll be progressing through the ray diagrams. Fine, note it down. I hope you have written. If you have written, let's take a break of 10 minutes. Then after 10 minutes exactly, we'll start with the formation of images of the concave mirror. Meanwhile, if you have any doubts, you can ask me. I'm here. So I think this much break was enough for you to freshen up yourself. Can we start now? All of you are here?
Yes, ma'am.
Krishna, Fatma, Aisha, Hamza.
Yes, ma'am.
All are here? All. Let's start with. Yes, rules for drawing the ray diagrams. See, first rule says that if you can have a scale with you, along with you when you are writing down, so it's better. Because free-handedly drawings will not work over here. And in your school exams, be in a habit of drawing this with the help of a pencil, if it's possible, because pen will make it look untidy. But just this much part, the principal axis with scale and this. Right now in your notes, you can avoid it the way you want to do, you can do it. Just for neatness, you can use scale right now. Okay, so yes, center of curvature will be there, focus will be there, and the pole will be there. These 3 points will be the reference point. The way you have 3 rays, incident ray, reflected ray, and the normal, three are the reference for the reflected rays. For the rays, you have these 3 main. For the points of references, you have center of curvature, focus, and the pole. Now first rule says that if rays are approaching from infinity or anywhere, but they are parallel to the principal axis, the rays have a tendency after reflection, they will pass through the focus. They'll pass through the focus. This is the first rule. Same thing, you can draw it for convex also. See, even if you have a convex mirror with you. This is a convex mirror. A ray of light will come. This will be the center of curvature. This will be the focus. This will be the pole. So if a parallel ray is coming, it will reflect by passing through the pole. Focus. Sorry. This is for convex because you have virtual images that in the case of convex. We'll see, we'll draw the ray diagram also, but this is the manner in which you can draw it. Second rule says if opposite happens. For example, please draw it with a scale if possible. Otherwise, it will become very confusing. Focus, pole. If a ray of light passes from the focus, if this ray of light is passing from the focus, then it will be parallel to the principal axis. Right? All these rules will be combined when you use them. And this is valid for convex also. If an image is passing from, it's just that sign of the arrow changes. Same diagram is there, just the sign of arrow has changed. This is a convex mirror. Center of curvature, focus, pole. A ray of light is incident and is passing through the focus. It will become parallel after reflection. For convex also same. So 2 points, both the points are same. Parallel ray through the pole, parallel ray through the focus. Now difference is if it is parallel, then it will pass through the focus. Opposite, if it passes through the focus, it will be parallel. 2 laws done. Third law is also very easy, but a very important law. You have a mirror, center of curvature, focus, pole. If any ray of light is passing through the center of curvature, this will retrace the path itself. Yesterday, on Tuesday's class, we did principle of reversibility. So similar to it. If you draw any incident that passes through the center of curvature, retrace it. for both the mirrors, for convex mirror and for concave mirror. Retrace it exactly the way its path has been. So for convex also, if you wish, you can draw it like this. Center of curvature, this is focus, this is pole. So if a ray of light is passing through the center of curvature, it will retrace its path. Obviously, behind the mirror, rays will not fall. That's why we are drawing dotted line. This will become clearer when we'll do the ray diagrams after this, when we'll apply this. Last says that, see, if any incident ray of light strikes on the pole, this is the focus, this is the center of curvature. If it strikes on the pole, making some angle theta, then exactly with angle theta, it gets reflected. It follows laws of reflection. Laws of reflection are followed. In this case also, for convex also you can draw. This is the pole, this is focus, the center of curvature. Here like this. So it will get reflected. Right? Like this. It follows laws of reflection, mainly the laws of reflection that we have studied. Two laws were there, no? Incident ray and the refracted ray and the reflected ray and normal lie in the same plane. These are laws of reflection. And here it retraces its exact path. So 4 easy laws, I hope you will be able to remember this. 4 first, parallel ray passing through the focus. Second law, any ray passing through the focus will be parallel. Both the laws are same. Third says, any ray that passes through the center of curvature, it will retrace itself. Fourth point follows the laws of reflection. If any incident ray is incident on the pole, exactly where that angle of incidence, the angle of reflection will be formed and the ray of light will pass through it. And the laws of reflection will be obeyed. Both the laws of reflection will be obeyed. So note down this, then we'll do for concave and convex mirror both simultaneously.
Teacher, can you please go to the previous diagram?
This
No.
one?
No, the one below this.
Oh,
Yes, teacher, I'm done. Thank you.
Done till here?
Yes, teacher.
Oh. See, formation of images by concave mirror. I think this you must have done it already in your 9th or 10th standard. This was included. So you can recall it, but this will still come with certain modifications. So this is a principal axis. This is a concave mirror. This is the pole. You have the focus. You have the center of curvature. Now the object is kept beyond C. See, the object is kept beyond C, beyond the center of curvature. At any point beyond the center of curvature, this is kept. So this point, let's say this is OA is our object. Now the rays will begin. This will be parallel to this. So it will pass through the focus. This is the first law that we had studied, that it will pass through the focus. And second ray will pass through the center of curvature. Now, we have applied the laws that we have studied. See, over here you are getting an image. Let me name it as O prime A prime so that you are able to distinguish. Now, what is the conclusion for the image that is obtained? Firstly, image is obtained between C and F, center of curvature and focus. First conclusion. Second, if you notice, what did I tell you in the first class? That if the rays of light actually meet at a point and intersect at a point, the image that you get is a real image. And this was OA, this is O dash A dash A, or you can say A is upwards, here A dash is downwards. So this is inverted also. And one more thing, this is smaller than the object that we have obtained. So this is smaller. Got it? This is beyond C. Now let's shift our object a little more between C and F. Beyond C we have done. See, if it was infinity, then obviously image will be formed at the focus. It will be of point size that you can figure it out because exactly the image will be formed at focus. If it is beyond C, these will be the conditions that will follow. If the image is formed between C and F, let's shift it a bit more. If image is formed between C and F, sorry, not the image formed, the object is kept. So this is pole, this is focus, this is center of curvature. Here your object has been kept. This is your OA, object has been kept. So what will happen to the rays of light? First rule will follow. Okay, before that, now let's keep it on the center of curvature. Let's keep it exactly at the center of curvature first. At center of curvature, I have kept the object. Now, rays will fall on this. Rays will pass through the focus. Now, if the second ray that passes through the focus, what happened? What did we study? If any ray passes through the focus, it becomes parallel. So this will become parallel. For these diagrams, no, prefer scale only because without scale, your diagrams will become incorrect. So this has to be the focus, not this. This has to be the focus here. Because I have not drawn the focus properly. No, I have drawn it roughly without any calculation. Focus has to be at the center between C and F. Now see image. Image is formed at C also. So if you talk about the characteristics of image, image is also formed at the center of curvature. This is again real and inverted. But now regarding the size, size is same. Same size is obtained as that of the image. Now we'll move on to what we were studying. At any case, if you're not able to understand or why the ray diagram or how the ray diagram has been drawn, any point, just stop me there. I'll repeat the point. This is third one between C and F. This is pole, center of focus, center of curvature, focus. Now between C and F, an object has been kept. This is your object AO. This has been kept. Now rays of light will pass through this first. It will be parallel. It will move through the focus because these rays of light are parallel. So these will move through the focus. Fine. Now, if rays of light pass from the focus, what happens? They become parallel to the principal axis. So this becomes parallel to the principal axis. Do you see the intersection? Here the intersection that has been formed. C class, here O dash, A dash. This is the image that is obtained. So if you talk about the image, what has happened? Object was between C and F. Now image is formed beyond C. Can you look and tell me, is it real inverted or not? This image, is it still real or inverted? Yes, no?
Yes, ma'am, it is real and
Yes,
inverted.
ma'am.
Yes, it is real and inverted. See, lines are actually meeting. So it will be real. And this is O dash, A dash. A dash is coming downward. So this becomes inverted. Hamza, can you tell about the size of the image that is formed? Is it larger than the object or exactly of the same size or smaller? Hamza. Fatima, can you tell?
It's bigger.
It's larger. Exactly. This is larger than the object. So here in this case, you get larger than the object. If you draw it properly with the help of scale, this will become more clear. This will become clearer than what I've drawn because I have drawn 300 on the screen. So for you people, it will become clearer if you draw. And last is if your object is kept between focus and pole. Object is kept between focus and pole. This is the pole, this is the focus, this is the center of curvature. Remember, focus will be at the middle of center of radius of curvature. That relation we'll see later on. See, if it is exactly at focus, the image will be formed at infinity. But if it is between P and F, now see what will happen. And if you're not able to see the image forming at exactly the point, do some manipulation, shift a center of curvature, focus and mid, but get your image exactly at the point. So this will be parallel. This will pass through the focus. Then the second ray of light, this will pass through the center of curvature. Now see, if you extend these lines, at this point, I am getting O dash A dash, this was OA. So now conclusions about image. Firstly, image is formed where? It is formed behind the mirror. Secondly, It is a virtual image because these rays of light are not actually meeting. We have extended it. These are appearing to meet at a point. So we'll say it's a virtual image, and you can see OA is here, so O dash A dash is here. There is no inversion. Tail together, heads and heads together. This shows that this is erect and large. So these are the conclusions for a concave mirror. One case is there for a convex mirror. I think let's complete that only. That also, so that you can write it at once. If it's a convex mirror, one case you have to remember for convex mirror. See, any case in actual, in your question paper, no, any case can be given to you. So you should be following the rules, whatever rules are given. But in general, these ray diagrams come. So this is the pole, this is the focus, this is the center of curvature. Now, for this focus, curvature, all are behind the mirror, and you cannot keep your object behind the mirror. So object will be always, it will be beyond pole. So at any place you'll keep, you'll get the same result. Now ray of light will come. This will appear to pass through the focus. This will appear to pass through the focus. Then you will have center of curvature at any point if you take. You have center of curvature. See, this will be the point, no, for center of curvature. I am drawing it like this only, roughly free-handedly. You do it properly with the help of scale. See, here I am getting an image, O dash, A dash. So conclusions about the image. Firstly, it will be formed behind the mirror. Secondly, it's virtual because again, it's formed by the appearance of the rays of light to meet. It's erect, but it's small. But this is just the case you have to remember for convex because all the things for convex are situated on the back side of it. So these 4 cases you have to remember. Draw these cases, whichever ray of light you're not able to understand, ask me. And for center of curvature, no, like this, just repeat this, retrace it. Yes, someone was asking something? No one? Okay.
What about the case where it's at F?
Yes, Atif, which case?
At F.
At F, no, that's what I was saying. For F, we have discussed in the rules that image rays of light that will come from infinity, those will only pass through the focus. So if images are coming from infinity, the image will be formed at focus. So point size image will be obtained because exactly at the focus you are getting the image. And reverse will happen. One more case, reverse will happen if the image from focus the object has been kept exactly at the focus. So image will be formed at infinity. That rule we have studied, that is exactly the same case. So if you want, you can write it separately as well, or you can include it in this one. But yes, do remember you have that case at focus. If object is at focus, image will be at infinity. If object is at infinity, image will be at focus. Why? Because we have seen the rules. So these 2 also you can add if anyone wants to. Otherwise, you can remember it from the rules. Fine, Asif?
Yes, ma'am.
Ma'am, can you scroll up?
Which point? This fourth point.
Third one, ma'am. Done, ma'am.
If you've completed writing the part, as you'll keep on completing, you can leave the meeting. This is for today. Yes, one more thing, class. On Monday, you'll have. On Tuesday, you will have a test on EM waves. After studying the rest of the part of reflection, we'll have a test because EM waves was left. So study the theoretical portion of it as well. Once you complete it, you can now leave the meeting.
Thank you, teacher.
Thank you, ma'am.